winter to give us one last blast, and then summer is coming. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 30th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure to like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. And you can also make a small contribution to the site using the special thanks button down below. A little heart with a $sign in it. Also, I'd like to take a minute to thank folks that have donated over the past 2 weeks. Sporman 2020, Elliot Harris, Ramil Sandikov, Peter Belden, RK Kinnett, Baja Bugs, Matthew Chase, Nap Time, and Sporman yet again. Thank you very much. All right, it's time to get to work. We'll start by looking at significant wave heights for the North Pacific Ocean, and this is probably the last time we're going to do any sort of an in-depth look up north. In fact, the reality is all the action is heading south. Anyway, for right now, the remnants of a gale off the Oregon coast, still generating 19-foot seas. First indicators of this swell starting to show up already in Northern California. Remnants of another gale previously off the Kuril Islands, generating 22-foot seas over the North Dateline region, and yet another little bit of fetch trying to develop off Japan. First off, we're going to do a quick look at current conditions by looking at the buoys. The first buoy, 029, right up here, Point Reyes buoy, off of a Point Reyes, California. We're looking at all the energy that's hitting that buoy, all the way up to 33.3 second period, real long period energy. There's a tenth of a foot of swell at 33 seconds hitting there. But clearly, something a little bit surprising at how big it is. At the 18-second period, 2.6 feet. At the 16.7 second period, 2.6 feet. So a good bump of energy. This is new swell from a gale. We'll get into that. That was previously off of Oregon. Then a whole bunch of wind swell, a bunch of small southern hemi swell, a whole bunch of other stuff all mixed in between. According to this primary swell, we're calculating 3.8 feet at 17.3 seconds from 299 degrees. That would produce surf of 6.6 feet in Northern California, but conditions are just a mess. It's blown out northwest wind and a bunch of whitecaps, so not really surfable. Then we go to the north end of Southern California, buoy 46053, the East Santa Barbara buoy. We see a little bit of energy in the 12 to 13 second period range here. I'm assuming that's probably southern hemi swell trying to sneak in a little bit, then some wind swell mixed in. Looking at this, primary swell, 1.7 feet at 12.7 seconds. Oh, from the west, 280 degrees. Okay, it's just a little teaser swell then coming out of the northwest. That would make surf at about 2 feet, so thigh high, something like that. Then we go down to Southern California, the south end, Point Loma South, buoy 191. Again, we see a little bump of energy. Here's that 14 to 13 second period energy here. That is southern hemi swell. You can see it right here. Primary swell, 1.7 feet at 14.3 seconds from 207 degrees. That would put surf at 2.4 feet or, thigh to waist high, something like that. Clearly there are bigger sets at top Southern California breaks that focus the southern hemi swell. And hooray, the Waimea Bay buoy is back, North Shore of Oahu, buoy number 106. Not a whole lot to report, though. Looks like pretty much just wind swell, little bumps of energy in the 1 foot range, anywhere from 7 seconds up to about 11 or 10 or 11 seconds, something like that. Primary swell, 2.2 feet at 10.4 seconds from 333 degrees. Surf is chest high at top spots, or at least it was this morning. Surf from primary swell right here, 2.2 feet. Yeah, Hawaiian, that's about chest high. Looking at the northern hemisphere and going back in time, so a gale developed off of Kamchatka. Let's put this all together here. Hawaii's right there, U.S. mainland right there, Japan there, the Kuril Islands, Kamchatka there. Okay, we'll say really maybe more off the Kuril Islands. Seas at 30 feet. This was on Thursday night, the 27th of April. It built to maybe 30 or 31 feet, something like that, as it went into Friday, pushing southeast. Then on Saturday started fading as it hit the date line. The date line's right there. But Hawaii's right there. You can see good opportunity for swell pushing towards the Hawaiian Islands. Also, looking here on Saturday morning, the 29th of April, a little gale developed here in the Gulf of Alaska, producing 25.9 foot seas, and that built some about we got 28-foot seas just barely there on later Saturday morning. Then the gale started fading from there. And like we said before, the leading edge of this swell is just starting to hit up here in Northern California. Much larger seas were up here off of Oregon this morning. Swell from this system bound into California come Monday. All right, so what's the forecast? We're just going to cut right to the chase. In the northern hemisphere, literally nothing is forecast from here. Yes, there is some areas of disturbed weather that might produce seas in the 15 to 16 foot range, but most of the focus now is on the southern hemi. So we're going to start there, looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. Let's get ourselves oriented. We're looking for a trough. That is a push in the jet to the north. There's New Zealand. Antarctica's down here. All right. Chile, Peru, right in here. Okay, and the U.S. West Coast off the chart up here, and Hawaii off the chart at 158 west, roughly there. All right, so right now we have the jet pushing south or southeast, and then down across the deep South Pacific. We want to see the jet making, it sort of looks like it's making a push to the north there, but it's all cut off. The main flow is pushing across it. But watch this as we get into right about there. As we get into Tuesday, this is Tuesday the 2nd of May, the jet starts pushing north. That's called a trough in the southern hemisphere. That creates a clockwise flow aloft. Now, in the southern hemisphere, rotation is opposite of the northern hemisphere. Creates a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, start getting traction on the ocean surface and generate seas. Seas start building as they radiate away from the fetch area. They turn into swell, and swell when it hits your beach turns into surf. So we have a trough forecast on Tuesday being fed by 150 knot winds, and let's see what it does from there. It gets even steeper and pushes further north, and that's what you want. You want the trough to push to the north as we get into Wednesday, and then it starts fading. In Southern California is about 118 west. The trough starts moving out of the Southern California swell window. So some potential there, and then we get into Friday, the 5th of May, yet another trough does the exact same thing, pushing north, maybe not quite as strong, being fed by 130 to almost 140 knot winds, but it too looks likely to help support gale formation. Now, what we're looking at in the upper atmosphere is not necessarily a guarantee of what's going to go on with a direct correlation down at the ocean surface, but if you don't have troughs, it's almost guaranteed you're not going to get any gales or any storms, and therefore no surf. So we start in the upper atmosphere. Then beyond that, as we get into Monday, May 8th, things kind of settle down a bit. Let's go take a look down at the surface. Here we are, surface level pressures, surface level winds. The southern hemisphere being so far away from Hawaii and California, between 45 to 5,000 to 6,000 nautical miles away, it takes a good amount of wind to produce meaningful swell. Minimum 35 knots, preferably 40 knots, and preferably a lot more than that. So on Sunday, not a whole lot going on. Yeah, some 30-knot winds here, but they're all aimed off to the east and not even in the Southern California swell window. Another little fetch here south of New Zealand, but you can look at the arrows, all aimed south at Antarctica. That does nothing. And this last little cutoff low here producing 30 to 35 knot winds over a tiny area and just not enough to do anything. But we know as we get into Tuesday, and here we go, here comes a building fetch of 30 to 35 knot winds aimed well off to the northeast. Let's see what they do. Building to 40 knots and aimed almost due north. Maybe that's good enough for some sideband swell for Hawaii. And look at that, 40 knot winds. We'll go back right there. Peak winds, it looks like about 6Z on Wednesday, so that'd be Tuesday night, the 2nd of May, aimed well off to the north, and then still continuing in some fashion even into Thursday, fading a little bit, but then right behind that, another gale starts building with another fed by another trough on Thursday night, the 4th of May, with 35 to 40 knot winds as we get into Friday morning, and even a small area of 45 knot winds aimed well off to the north. Look at that. That looks much stronger than the previous one with a tiny area of 50 knot winds on Friday evening and even continuing into Saturday morning, aimed well off to the north. Looks like a great swell producer if you believe the model's almost a week out. As we get into Sunday, that'd be the 7th of May, it finally fades out. So think about this. We're on Sunday, the 30th of April. A week from now, a gale is forecast developing. Another week after that, at least, it will take for that swell to radiate up into California. So at least we have a 2-week warning on the southern hemiswells, with some reasonable sense of accuracy, whereas in the northern hemisphere, you don't get nearly as much time. You get maybe a 5 or 6 day warning sort of thing. All right, so let's go take a look at the effect of those winds on the ocean surface. So here we are, surface level pressure, surface level winds. And let's be clear, there was a gale 2 weeks ago that produced, maybe it was a little bit less than that, produced a swell that arrived on, I think it was Friday in Northern California and made for some fun little waves. Nothing spectacular. Southern California did better. Select spots of Southern California were looking much better, but still surf in the nearly head-high range at best spots in Northern California, bigger down in Southern California. So we've already had one small swell to kick off the summer season. Now we know there's another gale that's forecast building. Let's see the seas that it's produced. As we get into Tuesday, the 2nd of May, seas start building to 28 feet. Right? Let's see. Yes, 20, 22, 24, 26, 28 feet, maybe 29 feet. Oh, there we go. 30 feet. Let's see. Sure enough. Okay, so this down here, 30 feet is the highest seas anywhere on this entire domain. And here's the coordinates of those seas, which happen to be right there. And the winds in that area also 41 knots aimed off to the northeast. So swell from something like that, probably 16-second period swell, and pushing pretty well off to the north. Not bad. Then we get into Friday, and another gale is forecast. This to be the 5th of May, with 29-foot seas, 30-foot seas, building to 34 feet, building to 37 feet late Friday night, and even 38 feet first thing Saturday morning. Mainly this not so much for Hawaii, because Hawaii is at about 158 and all this fetch is kind of aimed this way. This looks like a California down into Mexico, Central America, Peru, and Chile sort of swell. And then lifting north again Saturday morning, 38-foot seas, and then slowly fading from there. A pretty good long run of swell production seems likely. And then local wind forecast. So California right here, Hawaii right here. You just follow the barbs. So how do you read a barb? And I don't know if you can see these real well, but the wind direction follows the staff here. The flags give you wind speed. One full staff is 10 knots. A little half staff is 5 knots. So this would be 15 knots out of the east, pushing towards Hawaii. Trades basically for today for the Hawaiian Islands at typical speeds, 15 knots. And north winds building along the California coast, like I said earlier, full white cap mess, 20 knot winds, and that's what it was, if anything, even building right as the time that we're making this video. So we get into Monday, 20 knot northwest winds continue for North and Central California. Modest trades for the Hawaiian Islands. So we get into Tuesday, low pressure right over Northern California. You see it right here developing, falling south down the coast. Northwest winds back off a little bit, maybe 5 or 10 knots, something like that. Trades light for the Hawaiian Islands. As we get into Wednesday, the low actually pulls off the coast, generates some south winds for Central California and offshore winds for Northern California. If this low gets too close to Southern California, it's going to start drawing in southerly winds there. Trades for the Hawaiian Islands. So we get into Thursday, the low, sure enough, pushes right into Southern California, maybe potential for precip. We'll take a look at that in a minute. And southwest winds at about 10 knots. Light wind regime for North and Central California. Friday, trades building for the Hawaiian Islands, 20 knots. Light wind regime for California. Saturday, again, a light wind regime for California. Trades 20 knots for the Hawaiian Islands. And then we finally get into Sunday, a modest northwest flow down the California coast at 10, maybe 15 knots. Trades for the Hawaiian Islands. We want to see less of this northwest wind blowing down the California coast. That creates upwelling and just, water temperatures have been cold. Wasn't too bad in select spots, but north of Santa Cruz, it's 50 or 51 degrees and just not pleasant, not fun for surfing. Southern California, everyone is saying it's cold down there, but it's a lot warmer than it is up north. So hopefully the thought is that as we get deeper into May, this typical seasonal La Nina enhanced high pressure system out here that's driving this trade wind pattern for California will start backing off. All right, so we covered a lot of territory. Let's all try to put this together into some sort of a surf forecast. So this is for Half Moon Bay. We're just calling it Northern California in general. Now you see this is surf height building to 10 feet and then it drops off because there's a mixture of wind swell all mixed in there and the model gets confused of, well, is it wind swell or is it pure swell? But we could say surf in the 10 to 12 foot range as we get into Monday from the gale that was previously off Oregon. That's slowly fading as we get over time. And then some sort of swell building. We'll take a look at the details down here. So here is the pure swell, 8 feet at 13 seconds for Monday. As you get into Tuesday, it starts fading from about, we'll say 6 feet at 10 to 11 seconds, which is pretty much wind swell. By Wednesday, it's just all garbage. Then there's a little bit more westerly swell forecast coming in as we get into Thursday and Friday. Now, you can't really see it, but there's also southern hemiswell in the mix. You see these little spikes here? It's 15 and 16 seconds, and the angle's more from the south. 2 feet at 16 seconds, 2 feet at 15 seconds. That's new small southern hemiswell forecast in for late in the work week and the weekend. Looking at Santa Barbara, well, trying to get around Point Conception's a bit of an angle, especially for steep north-angled swells, which this next one is. So the model's suggesting here surf somewhere in the 2 foot range, probably coming from the northwest. And then all the southern hemiswell, for the most part, is all blocked by the Channel Islands. We'll take a look down here at swell size, 2 feet. Here you go. Half a foot at 12 to 13 seconds. That's the north swell. And then you can see the southern hemiswell here, 1 foot at 15 to 16 seconds sort of thing. But all of it just shadowed, unfortunately. We look at San Diego, a little bit of surf here, 2.5, maybe 3 feet mixed, probably with some wind swell. But then as we get to later in the week, you see this is again that Friday, Saturday thing, 3 foot surf. That does not include the enhanced bathymetry at, top south-facing breaks. So use your own scale to add a little bit more energy to that. Let's take a look here. Swell size, 1.5 feet at 12 to 13 seconds from the swell with a bunch of wind swell, 6 and 7 second period wind swell mixed in there. That all slowly fades. But then as we get, there we go, that's better. As we get later into the week when the southern hemiswell arrives, 1.9, 2 feet at 16 to 17 seconds and slowly fading as we get into Sunday. So good opportunity for surf there. And then the North Shore of Oahu, well, swell from the Kuril Islands is due in come late Monday into Tuesday. Surf heights in the 6 foot range, something like that. Then steadily fading from there. That's probably the last swell of any meaningful size for the north-facing shores of the Hawaiian Islands. Pure swell, 4 feet at we'll say 14 to 15 seconds sort of thing. And then some background swell. You can actually see some of the southern hemiswell trying to slide in here, but we'll go look on the South Shore for that. Here we go. Here's the South Shore forecast. Surf in the 5-foot range, slowly fading. That would be, about Wednesday? And pure swell, 3 feet, 3.3 feet at 15 to 16 seconds, something like that. And hanging on the whole way through the rest of the week, and likely more energy behind that. So pick your shore according to the swell direction. Then finally, winter is not over local weather-wise relative to California. So California is right here. The blue is rain. The white is snow. Things high and dry at the moment on Sunday evening. As we get into Monday, though, notice developing low pressure, a little bit of precip trying to build into the Pacific Northwest, and then even a bit of snow for Tahoe on Monday night. More rain for all of North and Central California as we get into Tuesday. Showers building into Southern California, snow for the Sierra. And then Wednesday, the low off the coast, probably still dragging some precip into the Central California coast. Then that low pushes inland with rain into Southern California as we get into Thursday with, did you see that there? Just a little bit more snow popping up in the Sierra. And then by Friday, I think it starts to wind down. Oh, not completely. Another little bit of showers for Northern California, north of the Golden Gate on Saturday, and then fading out on Sunday. Snow forecast dashboard for Olympic Valley. Theoretically, 10 inches of snow scattered over a whole range here. This morning's model runs had up to nearly 3 feet of snow. Now, that's clearly not believable. This is probably closer to the truth. We'll take a look at the snow levels. So very high snow levels, but they're falling. Colder temperatures moving in. You can already feel it in Northern California. The freeze level, white is freezing, blue is super cold. The 32-degree line is right between the gray and the white here. So snow level down to about 5,000 feet on right before sunrise on May 2nd, building up to maybe about 8,500 feet on the 4th of May, then falling back down. It just looks like an extended period of, so this is the base of Olympic Valley, this is the summit of freezing temperatures in the Alpine pretty much starting tomorrow and beyond that. And then looking at Mammoth, well, looks like about 10 inches there, too. We'll see how this all plays out. 2 shots on May 2nd and again on the 5th. Snow level, well, this is the base of Mammoth at about 8,000 feet. The summit up at 11,000 feet. Pretty much freezing temperatures starting midday on May 1st, the whole way through the foreseeable forecast, the whole way down to the base at Mammoth. So winter refusing to give up right when we thought it was over. Southern Hemi thinks that it's summertime, but locally, California, we're going to suffer a little bit more. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation? That's that periodic weather oscillation that affects the Pacific in good and bad ways over about a 6-week period for each cycle, be it either active or inactive. And then the El Nino Southern Oscillation, which can affect the Pacific for a year or two, or in the case of La Nina, we've just had 3 years. So we'll start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation. It has 2 phases, active and inactive phase. They rotate around the planet. Active phase on one side of the planet, inactive phase on the other. They rotate west to east on the equator. The active phase is like a low-pressure system, the inactive phase like a high-pressure system. When the active phase, the low-pressure system, moves over the Pacific, starts in the West Pacific, what it does is it acts like a chimney and sucks warm, moist air in the West Pacific up into the atmosphere. That in turn feeds energy to the jet stream, and a stronger jet stream produces more troughs, and troughs then in turn can produce storms. Also, the active phase of the MJO went over the West Pacific, dampens trade winds. That allows, in conjunction with the Coriolis force and rotation of the Earth, allows warm water that's piled up over in the far West Pacific to start sliding east. on the equator, but not on the surface. It actually, that warm water follows the thermocline down under the ocean surface. Takes about, 3 months to make the trip from the West Pacific to the East Pacific, but eventually that ball of warm water, it's known as a Kelvin wave, will erupt by Ecuador. And when it does that, it gets pushed up to the surface, makes a warm water slick there. If you have successive active phases of the MJO and they are strong enough, they can create successive Kelvin waves. And that can in turn create a much different water temperature pattern across the Pacific. And it ends up resulting in warm water building off in Ecuador and the Galapagos. That in turn creates more evaporation. That changes the Walker circulation, which then changes the storm track significantly in winter months in the northern hemisphere, but also affects the southern hemi as well. So the active phase of the MJO can be very influential and have a tremendous impact on surf production in the Pacific Ocean. So we're always looking for it. All right, so we're looking, what are we looking at here? Data from the TAO buoy array, a series of buoys strung across the equator. In fact, there's the equator right there. This is the far East Pacific here. This is the far West Pacific here. That is New Guinea right there. We're just looking at the arrows. We're looking at wind speeds across the Pacific. The longer the arrow, the stronger the winds, and you can see the arrow pointing, that tells you which direction the winds are blowing. So out of the east, moderately speed. Across the Central Pacific, moderate to almost strong in the Central Pacific, and moderate plus strength over what we call the Kelvin wave generation area, the West Pacific. That's the date line right there. When you have the active phase of the MJO, from anywhere from 170 west the whole way over to the far West Pacific, it'll dampen these winds. See, they're trades right now, and that then starts setting up the warm water. These colors are water temperatures, starts pushing them off to the east, the Kelvin wave thing we talked about a little bit earlier. But it's not the actual wind speeds. These are average wind speeds over the past 5 days. It's the anomaly, the difference from normal for this time of year. You can see, yeah, winds are blowing out of the east here, but looking at these arrows, pretty much normal, nothing stronger or weaker than normal. Same thing over the Central Pacific. Now, in the West Pacific, looks like winds are blowing a little bit stronger out of the east than normal. Though there is this one arrow here that's pointing sort of southeast pretty strong, but in general, this looks like the inactive phase of the MJO because the arrows, none of them are pointing off to the east. They're all suggesting, well, neutral trades or slightly enhanced trades. Let's go look at the forecast for the next week. So this chart has been updated. It used to be just a 1 week chart. Now they've made it a month-long chart, but we're just going to look 1 week out. This is zonal wind anomalies, the east-west component of the wind. Is it blowing stronger out of the east or out of the west? The blues are easterly anomalies. You can think of that as the inactive phase of the MJO. The reds, like here, are westerly anomalies. You can figure that as the active phase of the MJO. But this is the whole planet, so the date line runs right up the middle. The far West Pacific starts about 125 east, so right about there. Kelvin wave generation area ends just the other side of the date line, 170 west. So the main area we're looking at is right in here, and only for about the next week. So down here. So here we see easterly anomalies. That looks like the inactive phase of the MJO over the Kelvin wave generation area for the next week, but also the active phase of the MJO slowly building, almost reaching to the date line a week from now. So it looks like the inactive phase of the MJO is in control. That would explain those easterly anomalies we saw on the previous chart. And with the active phase, and these are pretty strong westerly anomalies here building in over time. All right, so let's go out 2 weeks. So another component of the MJO, we talked about east-west anomalies and winds. It's also cloud cover. If the active phase of the MJO is a low-pressure system, well, low-pressure systems generate clouds. The inactive phase of the MJO is like a high-pressure system. High-pressure systems create clear blue skies. So this is, they call it outgoing long-wave radiation, but just another fancy word for sunlight's ability to reflect off the ocean surface. The oranges and yellows here are clear, cloud-free skies. The blues, cloudy skies. So that would be the inactive phase of the MJO. That'd be the active phase of the MJO. So, and let's get ourselves oriented here. South America, Central America, Hawaii, New Guinea there. The equator runs right across here. Okay, the Kelvin wave generation area starts just a little bit east of the dateline. It's only 5 degrees north and south of the equator. So just a little area right in here. And what we want to see is blues here, but we don't. We see what is indicative of the inactive phase of the MJO right now. 5 days from now, inactive phase fading, active phase moving from the Indian Ocean into the Pacific. 10 days from now, active phase of the MJO in control and holding 2 weeks from now, 15 days from now. And this is a statistic model. This is a dynamic model, and lo and behold, look at this. They're painting almost the exact same picture here. I'll see. We'll frame up the last picture, the last run of the statistic model, or the last frame, and the last frame of the dynamic model, basically saying the same thing. Sure looks like the active phase of the MJO is getting ready to set up. And again, if the active phase is a low pressure system and it feeds energy into the jet stream, then that would be a big red X for a window for storm development. So it looks like we're moving from a period right now of not a great environment to support storm development to an environment 2 weeks from now, much better. That would be good for surf production. All right, so these are phase diagrams for these same two models, statistic model here, dynamic model here. What's a phase diagram? Well, it just sort of gives you a little bit more drilled in detail on what the MJO is doing, specifically just the active phase. All right, so the MJO, how do you read this? It moves from west to east, from the Indian Ocean over the maritime continent, that'd be like Bali, to the West Pacific, to the East Pacific, under the United States. Now, it's just on the equator, okay? Across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is today, so it's in the Indian Ocean. These are 3 forecast tracks from the statistic model, and so this circle here, the further this dot is away from this circle, like if it's way out here, then it would be a strong active phase, but this is a weak active phase because it's real close to the circle. Forecast moving almost into the West Pacific 2 weeks from now. According to the statistic model, the dynamic model suggests the active phase getting steadily stronger and moving into the West Pacific 2 weeks from now and at moderate strength. That's what we want to see. We don't want to see a wimpy active phase. We want to see a stronger active phase because, 1, that will feed energy to the jet stream in the southern hemi, and 2, it will also help potentially create yet another Kelvin wave, and we'll get into that in a minute. Then we go to the upper level model, and all this shows is yet another dimension of the MJO, the active phase. Shows potential for precipitation, moist air versus wet air. Active phase of the MJO, low pressure, is pumping warm water up into the atmosphere, or warm moist air up into the atmosphere. That creates precipitation. The greens are areas favorable for precipitation. The oranges and reds, dry air, not favorable for precipitation. This goes out 40 days. There's South America, Central America, New Guinea right there, the equator right there. The date line roughly right there. It's this area right here that we're interested in. And this is what happens in the upper atmosphere. That's about a week ahead of what goes on at the surface. So dry air exiting the Pacific, the inactive phase of the MJO. This would be the active phase of the MJO in the Indian Ocean, but starting to ease into the West Pacific, starting about we'll say the 10th of May, active phase of the MJO in control of the Pacific, and continuing making its trek. You can literally see it go the whole way across the Pacific on this 40-day window, and by the 9th of June, active phase out of here. So if there was a window for storm production, it would be somewhere right in here from, we'll say, mid-May to the early part of June sort of thing. And then you can see the inactive phase, dry air, moving into the West Pacific, we'll say late May into the early part of June. All right, let's take a look at the CFS model. This goes out 1 month. The forecast is down here at the bottom. This is what has happened. Again, this is the east-west component of the wind, zonal wind anomalies. winds at 850 millibars. That's up about 4,700 feet, but that's a good approximation for what's going on at the surface. The blues are easterly anomalies, and the dotted contour here, that is a indicator of the, you can see here, MJO, the solid contour, active MJO, the dotted contour, inactive phase. So inactive phase with the blues, easterly anomalies. We're going back in time. Here was a big active phase of the MJO in February and the early part of March, going across the Pacific. Oh, far west Pacific starts right here, 125 west. And this is past performance. This is the forecast down here. Kelvin wave generation area ends at about 175 or 170 west, so there. Anyway, active phase was there. There's a little inactive phase in March. A weaker active phase just finished, and you can see these are tropical cyclones or tropical systems of some sort. In early April, active phase. Here's our current inactive phase. It's kind of broken apart. You can see it moving west to east across the Pacific, but give it about another day or so, westerly anomalies forecast starting to build in the Kelvin wave generation area. And by about May 4th or 5th, westerly anomalies taking over the entire Kelvin wave generation area. You can see it right here because that's the active phase of the MJO moving across the Pacific. And it fades out towards the end of the model here, about the 25th of May. But notice, westerly anomalies fully in control. So this would be a complete, this would likely be the transition of a new pattern fully getting established in the Pacific. We've been talking since October of last year about the coming of El Nino and the development of westerly anomalies filling the Kelvin wave generation area. Why would I care about that? Because one, those westerly anomalies pump energy into the jet stream. Two, they help create Kelvin waves. Three, that's what makes El Nino. And of course, El Nino is great for making surf and for making moisture into California and snow. So it looks like the pattern, at least according to this model, is going to be fully realized and well entrenched. Give it about another 3 days. So let's take that not out a month, but let's take it out 3 months. This is the CFS model, 850 millibar zonal wind anomalies from 7.5 south up to 7.5 north, basically the main area on the equator. Now this is the whole planet again. The blues are easterly anomalies, the yellows westerly anomalies. This is past performance down here starting December 31st, and this is the forecast. And if you can ever see a transition, it's like, well, we had blues, we got some 1, 2 Kelvin waves, you know, but sort of a mixture of a balanced pattern of blue and yellows. And now you move forward starting in about 3 days from now. It's just solid westerly anomalies over the Kelvin wave generation area and building in strength as we get into June and July. Pretty impressive. Let's overlay the MJO. So the solid red is the active phase. The dotted contours are inactive phase. So notice in February, March, April, we were kind of active, inactive, active. We're currently inactive. But starting about a week or so from now, active phase. And then after that, it just sort of goes no real inactive, all active, the whole way to the end of the model. So La Nina is dominated by the inactive phase of the MJO in control of the Pacific. El Nino is dominated by the active phase of the MJO taking over the Pacific. So, and then when you're neutral, you have sort of a balance of active and inactive phases running back to back. Sure looks like we're moving towards a La Nina pattern. Good, moderate, active phase of the MJO forecast. Starting about a week from now. Notice we're in the inactive phase, and even with that, stronger westerly anomalies forecast on the dateline, and then they just continue until you get into the latter part of June, and then very strong westerly anomalies associated with an active phase of the MJO then. Now remember, this active phase of the MJO, and even this one back here in December, and this one here, all these have produced Kelvin waves, and it takes 3 months for those Kelvin waves to make it across the Pacific. So the one in February, well, let's see, end of February to March, April, May, that Kelvin wave is poised to hit Ecuador any day now. We'll get into that in a minute. Another one likely generated here in April to May, June, July. Another Kelvin wave probably for July. Yeah, and then this is going to turn into not distinct Kelvin waves, but just a steady stream of warm water piped the whole way across the Pacific starting May. So 3 months from that, May to June, July, August. Starting August, September, October, November, December, and that's your El Nino signal right there. In fact, let's overlay the low pass filter. So this is the high low pressure bias, or in easier terms, the La Nina El Nino indicator. Dotted contour right here is the La Nina indicator. Last year, even in December, it was fully locked over the date line, making westerly anomalies in the active phase of the MJO kind of hard to get hold. That said, in February, we definitely had an active phase that made it across the Pacific. Notice the high pressure bias pushing further and further off to the east. Today, it's centered it's south of California, but pretty much due south of California. And as we get deeper into summer, its sphere of influence, its width just gets weaker and weaker and weaker, while the low pressure bias, which has been over Bali for 3 years now, today, the peak of it right here is smack dab in the middle of the Kelvin wave generation area. The leading edge of the low pressure bias today is on the date line, and it's going to move further and further to the east. As we get to the end of July, it's going to be just off the coast of California. You would clearly suspect, if this model is even halfway believable, which it's done a pretty amazing job, that come October, November, December, things are going to get very interesting in the North Pacific. This is all what this model has been saying for months now, but it's still tracking exactly to what it forecast. All right, let's go take a look what's going on subsurface in the ocean. Again, data from the TAO buoy array, that series of buoys strung across the equator used for monitoring El Nino. And this is exactly what they're there for. They're really looking for Kelvin waves traversing the equatorial Pacific. This is the West Pacific here. This is the East Pacific here. These little X's or these lines, these are the anchor lines on those buoys. The buoys and the X's are sensors on the anchor lines going down. They record water temperature. When warm water starts pushing across the Pacific, you can see it here. This is the average temperatures. The 29-degree isotherm, about where it was last week, somewhere about 177 or something like that. The 28-degree isotherm, it might have been at 155 west last week. It might have given up a little bit of ground due to the current inactive phase of the MJO, and easterly trades a little bit stronger than they were a couple of weeks before, so that pushes the warm isotherm back. And this is degrees centigrade, okay? But the 26-degree isotherm, 25, the 24-degree isotherm, all just rushing the whole way across the Pacific. During La Nina, 24-degree isotherm was like cut off at 140 west, so a lot of warm water has already pushed into the East Pacific. But it is not the actual water temperatures again. It is the anomalies, the difference from normal for this time of year. And if ever there was a sign of Kelvin waves and warm water pushing east, well, here you go. 3-degree warmer than normal temperatures flowing from the West Pacific the whole way across, and then a Kelvin wave, it appears, impacting here with 3, 4, 5-degree above normal temperatures starting to build in the East Pacific. No break, continuous water, warm water. So this suggests that the El Nino pattern is already well established subsurface. Another chart showing the same thing. 1 Kelvin wave here. The second Kelvin wave, the leading edge was somewhere here last week. We think it's already starting to impact here, or starting to build, and all that, and then yet another Kelvin wave back here building. So 1, 2, 3 Kelvin waves plus warm water from 2 previous Kelvin waves already in this area. And you ask, why does this warm water go south and, go down under? And the issue is it follows the thermocline, and specifically I think it follows the 24-degree isotherm, which is right here, the warm water. So westerly winds start blowing here in the West Pacific. Take the warm water that's here. Now, too bad these sensors are out here because you'd see it's all red in here. It builds south or falls down, then follows the thermocline being held in place by Coriolis forces. So it goes right across the equator until it hits land, slams into Ecuador, and has nowhere to go but up. And you can see previous warm water from a previous Kelvin wave, all pulled up here, 28-degree temperatures towards the surface in the East Pacific, where previously it was much colder than 24 degrees centigrade. Sea level anomalies. So this is the height of the ocean's surface. Rather than using buoys to get what's going on down at depth in the ocean, you can take a satellite, Jason 3 satellite, polar orbit around the planet. It just sits there and loops. The planet rotates under it. Over a period of a week, it literally can map the sea heights of every square inch of the entire planet's oceans in about a week. You strip out the waves, the wind waves, and the tides, and you just see, is the sphere of the ocean higher or lower than normal? If it's higher than normal, why would that be? Well, warm water at depth expands. That'll create a bump on the ocean's surface. Cold water at depth contracts. That'll create a divot on the ocean's surface. So there's the equator right there. There's the date line. Chile, Peru, the Galapagos right there, Ecuador right here, and then Central America. Hawaii is up here, New Guinea right there. You can see 5, 10 centimeter anomalies the whole way across the Pacific, and then going to 15 to 20 centimeters and starting to spread north and south down Chile and up to Central America. Eventually that'll start working its way up into California. But also the warm waters here, now again, these are not temperatures, these are the height of the ocean surface in centimeters. But eventually the warm water here will do enough to cut into the high pressure system that's typically off California this time of year, start dampening trade winds. There'll be less upwelling. Then the sun will start beating on the ocean surface. And if you get that southerly flow, that actually it supports warming, and temperatures will start dramatically warming the whole way California, Central America. So we're at just the very, very beginnings of what looks like an El Nino pattern. And we're going to take a little bit deeper dive into that. And another view of equatorial upper ocean heat anomalies, upper 300 meters of the ocean surface. This goes back a year. This is the West Pacific here. This is the East Pacific here. The blues colder than normal water temperatures. The yellows and oranges warmer than normal water temperatures. You can see Kelvin wave, warm water pushing across the Pacific from west to east. Back in June last year, that did not do anything because then there was a massive cold upwelling response. La Nina last summer just held on. And then we got a little tiny, like a teaser, like an icebreaker Kelvin wave that tried to make its way across in the Thanksgiving time frame. And then January, Kelvin wave number 1. Here's number 2. Well, actually, number 2 is right here. Number 3 is embedded here, and it is massive. It's just starting to erupt. Ecuador is right here at 80. So Kelvin wave number 3 on the way. Sea surface temperature. Okay, we've talked the MJO thing. We've talked subsurface temperatures. Now what's going on the surface? All right, let's go take a look here. It's Chile, Peru, Ecuador, Central America, Hawaii right there, the equator right in here. These are sea surface temperature anomalies, differences from normal for this time of year. A clear, baking hot, warm event happening in Peru and Ecuador right now. You can also see that we know the trades are blowing here. They're dragging that warm water out across the ocean. It's to about 138 west. So Tahiti is somewhere right in this area here. Okay, it's just on the equator, 5 degrees north and south, so that'd be like from here down to about here. We expect this warm water, we expect this warm water here to get warmer, the trades to grab it and drag it across, and all this area warm considerably over the next 6 months. The trend for the past 7 days, sea surface temperature trend. Last week, things were like pretty much dead neutral here. No, it wasn't getting any warmer. Now, clearly, it was warm down here, but it wasn't getting any warmer. This week, we got warming temperatures building yet again along Peru and Ecuador. This is why I was saying we think another Kelvin wave is starting to show, or just the very early leading edges of it are starting to show. And then we've had this persistent warming pattern the whole way out to almost the date line, and that is continuing. And then the backed off view just showing much warmer than, so the official so the Nino 1.2 region is right in here. And that's kind of a noisy area, but that's where you look first to see if there's signs of El Nino. The official mature El Nino monitoring region is from 120 west, 5 degrees north and south of the equator, out to 170 west. Now we see very cooking warm temperatures in the Nino 1.2 region. We see a much more generalized light warming trend out here. Notice also this cooling trend, or the cool waters along California. High pressure sitting right here centered north of Hawaii, generating northwest winds, typical springtime kind of pattern. It's enhanced by the hangover of La Nina. Also note that the high pressure bias was sitting like right at 130 west. Not much of it left, but it's feeding this upwelling thing. We're going to have to suffer for a couple of more weeks, but my guess is between the seasonal changing and the building of El Nino that this thing's going to collapse at some point. And as soon as it does, water temperatures are instantly, by instantly I mean within a week or two, you're going to see a noticeable difference, improvement in water temperatures in California, and then at least up north, maybe the hooded 5, 4, and 5 mil booties won't be required quite as much as they have been lately. So let's put this into motion and see what's been going on. We're starting January 1st, 2023. Here's our La Nina signal. South America here, Central America, Galapagos right there. The date line right there, the equator right there, New Guinea there. Blues, colder than normal water temperatures. This is the classic La Nina signal. It's, when you see this sort of this triangle thing going from here down to here, with colder temperatures, that's La Nina. If it's warmer temperatures in this area, then it's El Nino. Now also notice warmer temperatures over the entirety of the planet's oceans. I'm not going to get into the political discussion there, but you'll see in a couple of minutes why there's some concerns around that. Anyway, let's put this into motion. We're just going to go week by week by week as we get through January, the 22nd, the 29th. Here we go, February. First Kelvin wave starts hitting. Temperatures start warming as we get into the 12th of February. The 19th of February, a little bit of a cool blast through the straits there. That's kind of a seasonal weather thing that happens, pretty much immaterial. As we get into March, temperatures moderate a little bit, and then as we get March 19th, really warm waters start showing up, building along Peru and Ecuador. April 1st, look at the warming. Very strong signal into the 8th. Into the 15th, pretty much peaks out. Things back off a little bit on April 22nd. And then here we are on the 29th. Temperatures look to be rebuilding. So I'm just going to toggle back and forth. That was last week. This is this week. Last week. And notice the warming out here. That was last week. This week. Building. So we're back on the train of building temperatures over the Nino 1.2 region and into the Nino 3.4 region. Then to put things in perspective, so the last super El Nino, the really big one, I mean, there was a very solid one in 2016, but the one that was really just caught everyone's attention was this one in 1997. So I went and pulled the data from the 29th of April from 1997. That's what that El Nino looked like this time. And now here's what this one looks like. So you can see this one, I'd say, is stronger in its coverage here, stronger than its coverage here the whole way out. But let's just verify that one more time. There we go. Yep. See, there was still cold water out here April 29th in the 97 El Nino, but in this year's El Nino, it is warm the whole way across the Pacific, much hotter off of Peru. This is the concern that has a lot of meteorologists worried, is that this El Nino, if 97 was a super El Nino, then what is the 2023 El Nino? Hard to say, but it is certainly a bit of a concern. Now, let's also play this one other game. Look at the temperatures here. We're going back to 97. Notice the cooler temperatures, you know, sort of a balance of cool and warm around the planet. Maybe you can slide this over so you can see that. You know, it's sort of an even distribution of warm and cold. Now look at this year's picture. There really isn't much cold. The worst of the cold is off of California. Otherwise, it's pretty much warm everywhere. That is, again, a political discussion for another day, but something to consider. Just to put a fork in it, sea surface temperatures in the Nino 1.2 region, that area right up there by the Galapagos in Ecuador. Temperatures peaked. They kind of backed off a little bit the past 2 weeks. Today, pretty warm again, 2.478 degrees above normal. El Nino threshold starts at a half a degree above normal. Now, the Nino 1.2 region is not the official El Nino monitoring region, but the Nino 3.4 region is. Temperatures there today, 318 thousandths of a degree above normal. Again, to get to El Nino, you have to be half a degree above normal. So we're tantalizingly close, but not there yet. And you got to do more than just be there for a day or two. You got to be there for 5 consecutive 3-month overlapping periods, which is, by the time you officially meet that category, you're deep, deep, deep in El Nino. We think we're going to be there soon enough. So what does the atmosphere think is going on, right? We talked about the atmosphere responds to changes in sea surface temperatures, and sea surface temperatures are changed by subsurface Kelvin wave movement, and Kelvin waves are generated by the Madden Julian Oscillation, the active phase of it, and the Madden Julian Oscillation is driven by the high and low pressure bias in the Pacific Ocean, or the lack of it. All right, so this sort of takes all that noise out and just goes, well, is pressure higher or lower in the Pacific than it would be? Okay, Darwin is in the Indian Ocean. Tahiti is in the Pacific. When pressure is lower in Tahiti, this index, they integrate these two numbers, you get a daily value. Today it's plus 12.76. If it's negative, that's the active phase of the MJO. If it's positive, that means higher pressure over Tahiti. That would be the inactive phase. So we have, well, we got a couple of days, 1, 2, 3, 4 days of the past 5, where the value has been positive. Okay, suggesting maybe the inactive phase of the MJO, and no big surprise. We saw that in all the other charts, so not surprising. Prior to that, though, negative, 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 until we got into April 14th. Prior to that, it was sort of a mixed bag of positive and negative. So all this looks pretty much like what we've seen on the MJO charts and other charts, that we're moving, the atmosphere is transitioning to El Nino, but officially we're not there yet. Otherwise, its daily contribution would be negative, and it would stay negative for a month on end. 30-day average takes some of the noise out of it. The value, minus 1.20. So that's pretty much dead neutral. Where were we a month ago? Okay, we got down to minus 4 or something like that at times, but we're just hovering around neutral right now. Why is that? We're waiting for that warm water to start building in the East Pacific. Exactly what it's doing. But until that warm water gets really established and the evaporation machine starts going, then that will tap into the jet stream, start changing the jet stream configuration. Then we'll start really moving to El Nino. So right now, we're still doing foundational work to just getting the underpinnings of El Nino set up. And given that it's, what, barely May. It's not even May yet, and we're this far along. It's pretty impressive. Okay, the daily average, 90-day average, this is looking back 90 days effectively. Plus 2.41. Where were we a month ago? Well, we were at 6, and actually months before that, we were way higher than that. In fact, let's go look at a graph. Here's the 30-day Southern Oscillation Index graphed out. Okay, the zero line is right here. We're going back to January 2021. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase of the MJ. You can clearly see the trend going upward for the past couple of years. We peaked out January, 10th of 2023. And now look at this, active phase. Here's your inactive phase, inactive, active. And we're just hovering. We know there's another active phase building right now. We expect to be pretty deep into negative territory as we get about 2 or 3 weeks out from now. Exactly what the models have been forecasting for months. The sea surface temperature forecast. This is raw data from the CFS model version 2 for the official El Nino monitoring region, the Nino 3.4 region. All right, so where are we today? We're at May, so somewhere the end of April. So this is the middle of April, so the end is right about there. Temperatures, according to this, are 0.3 of a degree above normal. That's about right. Forecast is as we get into July. Well, in fact, the El Nino threshold is 0.5 degree above normal. So we should be passing that somewhere in mid-May, we'll say. And then by mid-June, we should be up to 1 degree above normal. By July, we'd be tantalizing close to nearly 1.5 degrees. Now, again, remember, this is the raw model, so it overstates it a little bit. And anyway, by October into November, 2.3 degrees above normal. And I think that's what we had for one monthly reading during the 2015 El Nino, was about 2.3 degrees above normal. Maybe this El Nino would beat that. Now, this is the raw data. The PDF corrected, the more conservative version of the world, suggests temperatures to 1.2 or 1.25 degrees in July above normal, reaching up to 1.8 or 1.85 degrees in November, and then holding there. I suspect this is probably on the low side unless something strange happens. So regardless, this model suggests moving to El Nino. The PDF corrected, not super El Nino, just strong El Nino. The uncorrected says definitely super El Nino. Either way, it's a lot better than being in La Nina. So for right now, swell is building in Northern California. Raw Gulf swell. Swell is heading to Hawaii from the northwest. These will be the last 2 meaningful northwest swells of the season. Looking down south, it is nothing but southern hemi swell activity, and at least there is that. We've had one small southern hemi swell the past few days. It looks like potentially 2 more coming from more of a south angle, more focused on California down into Central America and Guatemala and that area. Hawaii still should get some sideband swell from at least the first of those next 2 forecasted systems. So the transition to summer is happening now. Looking longer term, El Nino development right on track, doing exactly as forecast. Next Kelvin wave, I mean, what we're really zooming in now is the next Kelvin wave hitting? How hot is it going to get? We're watching that 7-day average sea surface temperature heat trend to see what happens there by the Galapagos in Ecuador. And we're hoping by next week that it will be cooking down there, or at least getting warmer than it is this week. Certainly seems likely, if not next week, the week after that. Other than that, El Nino seems pretty much in the bag. How strong it's going to get, who knows? We'll keep watching. Again, it's hard to believe a model a week out, much less 3 months out, but the CFS model's done a pretty good job, at least this year, so we'll take it. Regarding next week's video, I think we're doing it on Sunday. If not, I'll try to do it on Monday. There's some things going on that I have to deal with. So we'll just, don't be too upset if it doesn't show up Sunday. I'll for sure do it on Monday. Other than that, if you enjoyed the video, give us a thumbs up, like and subscribe. That helps us get a little bit of money from these videos. You can always give us a super thanks too. We'd appreciate it. And other than that, we'll see you next week, Sunday or Monday. Same time, same channel. Thanks for watching, and be safe and be thankful for the surf that we're getting. All right, see ya.